Welcome to Global Tire Manufacturing. Join us as we explore the giant tire manufacturing process.
Welcome to NextGen-Build channel.
Welcome to the facility. We invite you to step inside and see how innovation drives us forward.
Welcome to the largest mining tire facility in the world. These tires stand over 12 feet tall and are built to withstand the harshest conditions on Earth.
We prioritize organization here. This section holds our rubber components, the heavy steel fabrications, and the industrial textiles.
We source our natural rubber from sustainable plantations. The rigorous quality inspection begins the moment the belt.
Synthetic rubber's unique polymerization provides exceptional durability and resilience against extreme stress.
The carbon black you see here is crucial for strength reinforcement. It dramatically improves the durability and lifespan of the materials we produce.
These high-strength steel coils are essential for the bead and belt construction. The beads secure the tire to the rim, while the
Starts. As you can see here, the ply structure is vital. The tightly wound layers ensure consistency and strength.
To achieve the desired consistency, we add the blue solution dropwise while maintaining a constant stirring speed of 500 RPMs.
The internal mixer, often called a Banbury, begins the critical process of compounding. Raw polymers and carbon.
This temperature-controlled mixing process allows us to achieve the ideal viscosity. As the data shows, we've reached the target heat for the reaction.
The voice explains how the visual compound discharge is measured, ensuring batch consistency across all samples.
As the superheated slab passes through these heavy rollers, the intense pressure causes it to elongate and thin.
We are now entering the stabilization stage. As the rubber sheets cool, high-velocity air and water misset the material.
Introducing the QuantuCut 5000, slicing materials with micron-level accuracy, achieving perfect dimensional stability.
This compound is crucial for maximizing wet grip. We blend the polymers at high speed to ensure the silica is fully integrated. This two-roll mill ensures the perfect blend for our sidewall compound. The milling process is crucial.
The structural anchoring of the bead wire is paramount to a tire's performance, ensuring it grips the rim securely under extreme pressure.
We form this bead precisely because of its importance in structural anchoring. It distributes the load and prevents the wire from pulling through the mechanism.
Step 1 is preparation. Ensure a slow and steady dip into the coating. Once fully submerged, lift the... In this demonstration of ply calendaring, the heated rollers apply immense pressure, bonding the fabric and rubber into a...
Results. These steel belts are coated in a specialized rubber compound, providing the puncture resistance you see here. This is the staging area. We organize all the components like these rubber sheets and bead wires just before they move to the tire building machines over there. This is the assembly stage, centered around the tire building drum. As you can see, the robotic arms are now applying the specialized rubber layers.
The inner liner is specifically designed as the air retention layer, preventing air from escaping and ensuring the tire maintains its pressure.
When we analyze the load-carrying structure, we must consider the forces acting upon the compression zone, right here.
The bead must sit perfectly in this channel. This is the rim locking mechanism which ensures the tire stays secure under pressure.
We've added these visual sidewalls specifically for impact protection, utilizing a polymer that flexes on collision.
We've applied these visual steel belts precisely for this reason. They maintain perfect stability even under the most massive loads.
The key to superior traction lies in the tread placement. These channels, highlighted in blue on the holographic display.
Stage 1, the green tire, still completely uncured. The unvulcanized rubber is malleable and tacky.
As you can see on the caliper, the dimensional accuracy is within the required tolerance.
and the concentricity check confirms the reading. We can proceed with the batch.
Welcome to the future of manufacturing. Here, the process begins, utilizing high-pressure steam to...
As the press closes, the extreme pressure application begins, generating forces powerful enough to deform the structure of the steel.
By introducing sulfur to the raw rubber under high heat and pressure, we create these essential crosslinks. This visual timer highlights the importance of the curing duration.
Without adequate time, the concrete won't reach its required strength.
With the mold open, the final tire shape is revealed.
We have to wait. The brake assembly is still glowing hot.
Give it a few minutes to cool down before we use the gun. The system is now actively reducing the temperature. The introduction of the cryogenic vapor ensures a precise and
We use the blade at a 4 to 5 degree angle to trim the excess rubber, leaving a perfectly smooth finish like this.
We utilize a digital tread depth gauge to verify the accuracy of the pattern.
This ensures that every groove and sipe meets.
The visual X-ray scan reveals the component's internal structure. A critical defect has been identified. Internal stress fracture, type A.
Check-ins. We utilize visual shearography for structural integrity verification. The laser scans the composite.
Rotational stability is crucial for accurate visual balance testing. As you can see with this top, the faster it spins, the more stable it becomes.
We are exceeding the design parameters now. The thermal load is spiking. As you can see, the central structure is...
The labeling explains the size and specifications. P225 is the type and width. The 50 is the aspect ratio.
The purpose of this visual serial number engraving is to ensure complete traceability. This allows us to track the product through its entire life cycle.
The certification is complete. This tire meets all quality standards and is approved.
The sheer power of these machines allows us to stack containers 6 high, optimizing space in this busy terminal.
Welcome to the future of inventory management. By optimizing our warehouse storage, we've increased efficiency by 20%. Our integrated global platform optimizes delivery routes in real time. As you can see, the Australian shipments are froze.
Managing the logistics of oversized freight is incredibly complex. We optimize routes daily.
From these rugged slopes, the raw materials are extracted, beginning their journey to the factories across the globe.
Proper alignment is crucial here. Next, we use the pneumatic torque wrench, applying the precise tightening sequence to secure the wheel.
Standing over 13 feet tall, this haul truck tire alone costs upwards of $60,000, dwarfing the engineer beside it.
Failing to maintain this unit, specifically checking this gauge, can lead to costly downtime. That's why this inspection is crucial.
Now, if we look closely at the shoulder, the feathering here tells us we have a severe toe-in problem. This affects both handling and longevity.
Let's look closer at the internal structure again. This central gear assembly is where the main articulation occurs, which is crucial for the stabilization.
Once the tire is maneuvered into position using the overhead crane, we ensure the studs are aligned before sliding it onto the hub and securing the lug nuts.
Turbine. When fully inflated, this tire alone weighs nearly 11,000 pounds. It is one of the largest tires in the world.
This quarterly inspection is vital. By identifying potential issues now, we ensure the stability and efficiency of the entire data center infrastructure.
As you can see here on the shoulder, the tread is wearing much faster than the center. This indicates consistent underinflation. As you can see in this cutaway view, the quantum core regulates the energy flow. The plasma injectors then route the fuel to the modular frame.
In slow motion, we can observe the load distribution in real time. The heat map clearly shows the areas under the most significant strain before failure.
The heat buildup rapidly approaches critical levels here. But once the thermal management system engages,
we're simulating high-velocity rock impact to ensure the material meets the strictest durability requirements. As demonstrated, it withstands the impact flawlessly.
Designing a vehicle for this environment meant rethinking articulation. The chassis must twist independently.
The chart illustrates the direct correlation between tire wear and operational hours.
After careful inspection and buffing, we apply the new tread. This sustainable practice saves a significant amount of raw materials and energy. Once the worn tires are returned, they are placed on this conveyor system, which moves them towards the shredder to begin the recycling process. We're giving these tires a second life. Through our reclaiming process, we break down the material and turn it into these pellets, ready for reuse in new products.
Powerful electromagnets efficiently separate steel from other materials. This closed-loop system ensures nearly 100%.
As you can see, Our global emissions dashboard shows a 40% reduction in CO2.
Welcome to the facility. Remember, safety is our top priority. Always stay within the authorized zones and know the location of your nearest emergency stop.
Templarry. Visual automation, the future of manufacturing. Sub-micron accuracy ensures flawless assembly. 24/7.
Expertise isn't born overnight. It's the culmination of thousands of hours, knowing exactly how the wood will react to the blade.
This is the breakthrough we've been waiting for. The optics in this prototype double the field of view while reducing the form factor significantly.
We have to ensure every weld meets the exact specifications.
This factory proves that skilled labor is the backbone of modern manufacturing.
The simulation highlights the stress points in red. But watch what happens when we apply the optimization parameters.
These next-generation prototypes utilize a bioadaptive polymer, allowing the tread to change shape based on road conditions. We're developing next-generation materials, lighter than air compounds, combined with fibers significantly stronger than traditional alloys.
Activating visual monitoring system, high-resolution 3D mapping and real-time diagnostics.
The global demand for raw materials means these colossal tires, costing as much as a house, are in constant high demand worldwide.
The worldwide demand for these colossal tires is unprecedented, driven by extraction efforts across the globe.
The core of our manufacturer identity lies in the balance between precision engineering and our commitment to sustainability.
This achievement belongs to every single one of you. Your innovation and commitment made this possible.
From raw materials to finished product, our automated assembly line works around the clock, ensuring peak efficiency and
purity. As you can see, this kitchen was stuck in the 90s, but we've completely transformed the space.